Now let's move our attention over here to another type of situation that we might encounter, and that is a circuit with dependent sources, but one that would lend itself better to doing mesh analysis rather than nodal analysis. And why might we choose mesh analysis for this particular circuit? Well, in this case, you might see that we have one node there, another node, two nodes, 3 and 4, and then we got to pick one of them as a ground point. And so we'll have at least 3, maybe less equations, but at least 3 there. And then we have a couple of current sources here, which actually gives us values here since they're on the outside. They give us values for these two meshes up here at the top. This what we might call mesh 1, and this one mesh 2. And because of that, we'll find that we will have only 2 more meshes to solve for. But either way, I think you might find it'd be about the same amount of work. But for the sake of this, let's do a mesh analysis. So again, let's label this as mesh 1, this as mesh 2, and this guy is mesh 3, and this one is mesh 4. All right, so looking at these, we can easily see that for mesh 1, well, that I1 equals 4 milliamps because there's an independent 4 milliamp current source there, and it's on the outside, it's not shared with anything, and so that is the current in that mesh. For mesh number 2, we have sort of a similar situation, except for, in this case, it's not an independent current source, it's rather a dependent current source, but we can still say that I2 equals the value of that dependent current source, which is Vx over 3K. So let's look real quick at what else we can say in this particular situation. Well, we can say something about the value of Vx. We can actually say that the value of Vx is equal to 3,000 times the difference between the I3 current and the I1 current. So 3K times I3 minus I1. And can we say anything about the value of Ix? Yeah, actually we can. We can say something about the value of Ix here. We can say that Ix is I4, right, minus I2. All right, so now let's move on to our other 2 meshes. We have a third mesh, mesh number 3. And for that, we can start with the value of 4K times Ix, and it's minus 4K times Ix. Plus then we'll have 3K times I3 minus I1, plus we'll have 1K times I3 minus I4, and that must equal 0. And for mesh number 4, we can write 1K times I4 minus I3 plus 4K times I4 minus I2 plus 15, and that must equal 0. So now that we have our 4 mesh current equations, we can start to do the process of simplification in order to solve fully. And the first process of simplification that we're going to want to do is be able to plug in I sub x for, which is I4 minus I2. And then the other simplification is anywhere we have an I1, of course, we'll plug in 4 milliamps in that particular case. So that would occur, say, right here in the mesh 3 equation. So performing the simplifications, we'll rewrite everything up here on the top right. So for number 1, we get, of course, I1 equals 4 milliamps. And in the case of this, let's go ahead and work in milliamps and kiloohms, and we don't have to worry about doing the milli and K. We just know that when we're going to solve the currents for this, it's going to be in terms of milliamps. And that's only possible because milli, which is 10 to the minus 3, cancels with 10 to the 3, which is kilo. So this is a milliamp kiloohm conversion that we're abstracting out in this case, just to make things a little bit simpler, make the numbers look a little nicer. But just remember that at the end, our current values are going to be in milliamps. So for number 2, mesh number 2, we'll plug in for Vx here, and when we do that, we get I1 plus I2 minus I3 equals 0. And then for number 3, moving a bunch of things around and solving, substituting for I sub x here, and then distributing out the 3k and 1k, and doing all that organization, we'll get an equation that is 4i2 plus 4i3 minus 5i4 equals 12. And then for equation number 4, we'll get minus 4i2 minus i3 plus 5i4 equals minus 15. And so this gives us our system of equations to solve, and we can put this in matrix form. So let's go ahead and write our matrices here really quick. And we can say, well, since I1 is the only part of mesh number 1, we can say that 1, 0, 0, 0 equals 4 over here. And again, we're going to do the 1K milliamp conversion. And so that's I1 there. And then for the second equation, we'll say 1, 1 minus 1, 0, that's I2, equals 0. And for the last one, we'll say 0, 4, 4 minus 5, and that's for I3, equals 12. And then we'll say 0 minus 4 minus 1, 5, and that's for I4, equals minus 15. And when we solve that and we plug it in to say something like MATLAB, we find that, of course, I1, as we already know, is 4 milliamps, I2 equals minus 5 milliamps, I3 we'll find as minus 1 milliamps, and I4 equals minus 7.2 milliamps.